You know, whether it's the slowest plant or the fastest animal, every single living thing has this amazing ability to sense what's happening and react to it. So today we're going to dive into the incredible systems that make all of that possible. I mean, how does life pull off this amazing feat? Let's find out.
Okay, so let's start with something we can all relate to. Ever wonder what's really happening in that split second you touch something hot? You know the feeling, right? Your hand brushes a hot pan, and before your brain even says ouch, your arm has already yanked itself back. How does your body make that impossibly fast, life-saving decision?
Because that moment of contact, that's a real emergency. We're talking about a super dangerous situation where your body has to act, and I mean instantly, to stop you from getting a serious burn. Yeah, think about it. If you actually had to think through it, that's hot. Heat can damage my skin. I should probably move my hand now. Well, by the time you got through all that, you'd have a nasty burn. Thinking is just too slow in these situations. That's why your body has this incredible automatic override system. And that override is all powered by the body's own super fast communication network. What are we talking about? Well, it's the nervous system, of course. So the nervous system, just think of it as your body's own dedicated fiber optic network. It's literally a web of nerve cells, or neurons, that act like biological wires. And they're built to do one thing: carry tiny electrical messages at absolutely insane speeds. We're talking up to 260 miles per hour. It's basically an instant communication grid. And here's how that signal makes its journey. It's a 5-step process, really. First, special receptors in your skin scream hot. That creates an electrical impulse. That impulse then zips down a nerve cell, has to make a tiny leap across a gap called a synapse, and finally, bam, it hits the muscle cell on the other side. Right, and this is the moment of truth. This is the neuromuscular junction. It's where the electrical signal gets handed off and becomes a physical command. The nerve tells the muscle, hey, contract, now. It does this by triggering a chemical release, which makes all these tiny fibers inside the muscle pull together. The whole muscle shortens, and that's what physically yanks your hand away. Okay, so here's the secret sauce. How is it so fast? It's all because of this brilliant shortcut called the reflex arc. In an emergency like this, the signal doesn't waste time going all the way up to the brain for a decision. No way. It just goes to the spinal cord, which acts like a local manager and immediately sends a command straight back to the muscle. We're talking a round trip that can take as little as 50 milliseconds. Your brain finds out what happened after the fact. The action is already done. Your hand is already safe. But of course, we're not just a bundle of reflexes, right? For pretty much everything else we do, all the complex, voluntary stuff, we need to get the big boss involved. Your personal command center, the brain. And this chart lays it out perfectly. You've got two completely different paths for a signal. The reflex arc, that's the spinal cord superhighway. It's instant. It's automatic. You don't control it. Then you have conscious thought. That's the scenic route through the brain. It's slower, but it's voluntary. It's the difference between yanking your hand from a flame and deciding, I think I'll pick up that pencil. And here it is, the supercomputer running the whole show. The brain is the heart of your central nervous system, and its job is just mind-boggling. It's constantly taking in a flood of signals from your eyes, your ears, your skin, everything. Then it mixes all that with your memories, your emotions, your past experiences, and somehow makes a decision about what to do next. It's incredible. And the brain isn't just one big gray mass. It's got different departments, each with a specific job. You've got the forebrain, which is the main thinking part. It's where you process your senses and make voluntary choices. Then there's the hindbrain, which handles all the background stuff you never think about, like breathing. And then you have the cerebellum, which is like a little acrobat, managing your balance, your posture, and all your precise movements. So that electrical system is amazing for sending a lightning-fast message to one specific muscle. But what if you need to send a message to your entire body at once? Like, what if you need to tell every single cell, hey, get ready, something big is about to happen? For that, you need a totally different system. The chemical messengers. Yep, we're talking about that classic primal command, prepare for fight or flight. That feeling you get when you're suddenly startled or scared. Your body has to switch gears instantly to get you ready for some serious physical action, either to fight off a threat or run away from it. And this is the adrenaline rush in action. That one chemical signal gets broadcast throughout your whole body. Suddenly, your heart is hammering in your chest to pump more oxygen to your muscles. You're breathing faster. And your body even diverts blood away from things like digestion and sends it straight to your arms and legs. It's an incredible, system-wide preparation for peak performance.
The system responsible for this is the endocrine system, and the analogy here is perfect. If the nervous system is a targeted high-speed fiber optic cable, the endocrine system is like a wireless broadcast. It uses chemical messengers called hormones, which get dumped right into your bloodstream. It's a bit slower, sure, but that message can reach every single cell in your body.
And the factories that produce these hormones, the endocrine glands, they're not all in one place. They're scattered all over your body. You've got them in your brain, your neck, your abdomen, and together they form this network that coordinates all the long-term stuff, like how you grow, how you use energy, all of it. All right, so we've got animals covered with their fast electrical wires and their slower chemical broadcasts. But what about plants? They don't have nerves, they don't have muscles, so how in the world do they respond to anything? I mean, it's a really good question, isn't it? We kind of think of plants as just sitting there. But they're not. They are constantly reacting to things, to a touch, to where the light is coming from, even to gravity. So how do they do it, without any of the equipment we've been talking about? Okay, check this out. This is a perfect example. It's called a sensitive plant. On the left, you see its leaves are all spread out, but on the right, just from a simple touch, the leaves have completely folded up on themselves. That is a super fast movement for a plant. And remember, there are no muscles involved here. So what's the trick? Well, it's actually caused by a sudden change in water pressure. The plant sends a signal that tells special cells at the base of each leaf to dump all their water fast. Think of those cells like tiny, stiff water balloons. When all the water rushes out, they suddenly go limp and the whole leaf structure just collapses inward. It's not muscle, it's hydraulics. How cool is that? But plants don't just have these fast, dramatic reactions. They also have a much slower, more patient way of responding. They literally move by growing. I mean, look at this shoot bending towards the light. It looks like it's moving, but what you're really seeing is a very carefully controlled growth spurt. And guess what they use to control that growth? Hormones, just like us. There's a plant hormone called auxin, for example. When light hits one side of a stem, auxin builds up on the shady side. This makes the cells on the shady side grow longer, which physically bends the whole stem toward the light. It's brilliant. And they have other hormones too. Some to kickstart growth, others to put on the brakes. So you've got nerves, hormones, water pressure, and light. From a nerve signal firing at 260 miles an hour to a plant slowly bending towards the sun over a few days. It's just incredible how many different ways life has figured out how to respond to the world. And what's really amazing is that even though they're so different, both animals and plants use these similar ideas of electrical signals and chemical hormones. It really makes you wonder, right? What other invisible control systems are out there all around us shaping the life we see every day?